Now, as we review the free response from day 7, on part A here, hopefully you've already read the scoring rubric. If you have not, please do so and go back. It's some really good information. We know for part A, either saying a completely randomized design or doing a block experimental design would have worked for this. Look at the scoring for this one. I think it's important to know to get an E or an essential on here. You have to talk about how you create the two groups of equal size and also assign the named treatments to the groups. So they are looking for that specification in there. You know, for part B, what to take away, again, in the scoring rubric, which is under question 3, it's the second page of question 3's answer, there's the word and in there. They're looking for a few things. One, that your example shows the reasonable characteristics, but in addition, they underline it. They say that it explains how this characteristics could be associated with changes in the difference. So you have to be able to highlight the difference between that pretest and that post-test part. Feel free to let me know if you have any questions about this one, but you should have self-scored it. Switch gears out of observational studies into experiments. We had a handful of more learning objectives to discuss, and let's kind of look at some of the key summary events. Really knowing the difference between an observational study and an experiment is going to be vital in this case. Knowing that the explanatory variable is almost like our input and the response is the output, it's kind of like the X and the Y. Lurking variables and confounding is going to be an important thing. One thing to keep in mind is this, a question people will have about lurking and confounding is that does confounding mean there is a lurking variable, or does it mean there could be a lurking variable? If you have confounding in an experiment, then it means there was a lurking variable you did not control for. That in itself was strong enough that it caused the response to be changed. So it's possible to have lurking variables out there that don't confound. They're not going to make a big enough impact. But there could be some lurking variables that are strong enough that they will confound and they could change the response. Now you can control for the lurking variables by just designing your study more smartly. One thing I do see the AP board sometimes reference are these basic principles of experimental design. Remember, one of them is control. You can control for the lurking variables, like I said, on how you design a study. If you want to For example, if you want to test how caffeine affects someone and you want to give them a sugared soda, then you need to make sure you control for it and you don't have the other soda be a diet soda, because that sugar content or that saccharin content could be a lurking variable, so you can control for that. Random assignment of the treatments is very important. That's why we create SRSs to have a good assignment of our studies. And then replication. Remember, replication in this case means using enough experimental units. It means having a large enough sample size. Talking a little bit more about random assignment, the one thing that it is really good is this last statement, is that randomization and comparison together really help prevent the bias amongst various people in your study. Things to keep about the difference between double blind and single blind. What is the placebo effect? I already mentioned it in our video the other day about blocking. Remember, you block in experiments, you create strata or stratify when you do observational studies. Matched pairs is a big one. When is it that you're comparing two samples, or when is it when you find the difference of those two samples and you do a matched pairs, so you really have one sample that you're looking at? You want to be able to think about the scenarios for matched pairs. You can match two different ways. You can have one subject have two different treatments and find the difference in that, or you can have two different subjects each getting a different treatment. If you choose that method, you want to make sure your two subjects are matched by likeness and are similar in comparison. Some other things to keep in mind, how to randomly assign to a group in an experiment. When you're asked to design an experiment, you must explain how you're doing the random assignment. Be detailed in that explanation. A nice way to do that, the equal size pieces of paper from a hat is a nice, safe way to do it. It's not the only method you can use, but it's a safe one. Make sure to talk about that you are going to compare the response variables at the end. These 3 bullet points were really, remember when we made the diagrams, how you randomly assign your SRS, you go into different treatments, and then you compare your results at the end. Now, the last bit here, I do want to reiterate the 3 principles of experimental design. We kind of touched on it. But it's really good for you to understand this. Again, replication. What do you do for replication, and what does it actually do to your experiment? Control. How do you control, and what does it actually do? And then randomization, the same thing. How do you randomize, and why are we doing it? So with that being said, those are the key highlights from section 4.2. So like this little guy here says, keep focused, you got this, stay on task, try today's multiple choice questions, and then this free response. Take a look at that one, and then once you do it in your packet, go ahead and look at the scoring rubric and see how you did. Free response from today is from 2001. It is a question, is problem number 4. So take a look at it. It's kind of interesting. We really haven't seen these types of graphs before, but see how well you can do, and again, score yourself, and we'll start tomorrow's video with some highlights on that scoring rubric.